Hello and welcome to the second part of my space shuttle design and construction tutorial. If you may have noticed, the recording quality has improved substantially since the last one, and that has to do with my gaming headset being retired from voiceover duties and replaced by a Blue Yeti. Alright, gonna get right into this. In my previous video I said I was going to keep the total number of modded parts to a minimum. I really don't know what I was thinking when I said that. To clarify, I'm going to try to keep the total number of mods required to a minimum. This is going to be primarily all modded parts. There's just really not a lot in the stock pack you can do to make a space shuttle. So that disclaimer out of the way, I'm going to start with the first mod in the list, which is B9 Aerospace, and all the attendant fixes to make it 2.35 compatible. I'm using the Mark V cockpit system, which there's no IVA worth talking about, which is quite a bummer, because the B9 IVAs are usually really good looking, but that's neither here nor there. HL fuselage adapter, monopropellant tank, back that off, fuselage body, everybody's best friend, the cubic octagonal strut, inline clampetron, and just because this save uses TAC life support, I'm going to put a small life support container there. Totally optional if you're not using a life support mod, just ignore that. Go back to the structure, put a single 8-meter cargo bay there. Going to use an HL fuselage LFO tank, and that's just for the OMS system, or the orbital maneuver system, to circularize your orbit, to deorbit, what have you. Have another monopropellant tank. Put a lot of RCS in this ship, not because it necessarily needs it, but because these two can act as ballast tanks on your reentry, so you can shift your center of mass forward for more stability, and once you've slowed down from your high Mach numbers, shift it back to improve your glide ratio so you're not having to keep the nose up all the time just to maintain level flight, which will slow you down very rapidly because there's a lot of drag produced by that. Cap it all off with another fuselage body. And go back here. Yet another cubic octagonal strut. Drop that approximately there. Now, the most critical thing about the space shuttle is having an engine that can gimbal and fire through your center of mass, which the Clockheed Martian pack can do pretty well. It's actually takes a lot of the guesswork and difficulty out of it. And as I'd previously raved, just look at the hotness that is that engine. Okay, wiping away the drool, getting back to construction. Going to throw in 2 more cubic octagonal struts, turn off angle snap, put them in symmetry. And this engine, because of the slanted base, it will not do symmetry. You can see you got an upside down motor there. There is a definite up and down side to these engines. It orients the gimbal correctly, but so I'd go symmetry off, slide it in there, get the other one in there. So many nodes. And there you go. Primary propulsion is complete. Going to sort out our aerodynamics now. 4x2 delta wing as a vertical stabilizer, turn angle snap block back. That is not the correct thing. Or was it? Yeah, it was. Just wrong angle. Put a 4-meter control surface on here. And at this stage, I'm using, this is all stock, B9, Aerospace, and Clockheed Martian parts. Those are, B9 Aerospace and Clockheed Martian are the only mods up to this point. Going to sort out my wings. Well, no, I want to get my mass at least correct. Radial engine mount for Gorf engines, turn off angle snap, symmetry, slap those there, and the Clockheed Martian pack, you can use whatever small engine you like for your OMS. They come with some purpose-built OMS engines. These do not gimbal, so they have to be right on your center of mass or very accurately aimed. I tend to use these OMS micro shuttle engines. They have the same gimbal ability as the SSMEs. They will target your center of mass, but it's just, I like the way they look, and the gimbal makes, I'll get into that later. That's a lot to really explain all at once. But same problem, you shift them too high and you're shooting over your center of mass, and that tend to pitch the nose down. Put them too low and they tend to pitch the nose up. But these SSMEs take up so much room that you can put your OMS pods on the side, which is really convenient, but for aesthetic purposes I just stick them on the back. But I'll just show you real quick. When you're setting up your OMS thrust for your center of mass, take thrust limiter down to 0 on the main engines. And if I were going to do my side mount OMS system, get your center of mass displayed, turn on your angle snap and symmetry, slap those there, and then whatever engine you want, I'll put the non-gimbal on there. Your center of thrust, because we disengaged, we turn thrust limiter off on these. That's pretty close. Turn off angle snap and you can get it darn near exact. But as I said, I'm going with a slightly different path because I can't do, oh, that's the 1 meter. No, that was the 1 meter. Can't do the big OMS pods like the Space Shuttle actually has. This is going to be kind of as good as it gets. Shot right through to the center of mass. Go in here. Oh, not that. Control Z is your friend. And put in some small batteries. These are actually from the Interstellar pack. I just like the look of them. Free to use whatever battery tickles your fancy. And then I like to add the N2 large Omnilight, again a B9 part. For cargo bay illumination. Alright, primary mass has been added. Lost my engines apparently. There. And now it's time to sort out the aerodynamics. 4x6 delta wing, put it just below thermal tiles. 4x4 square wing, kind of build it back up. And you've got an option here. I typically use this wingtip. It's got a nice control surface built into it, and you put another 4-meter one there. But there's some other concerns that I've run into that I can illustrate better using this setup, which doesn't quite look as nice, but I can just kind of show some other things to be aware of. Okay, that's gonna be no good for a high Mach re-entry. When you do your S-turns to slow down and bleed off that airspeed at high altitude, that will let the rear end pivot around. It's a large aircraft, there are no secondary control surfaces, no canards. I'm not going to put any cheaty fake tail fins on the back to make it actually just a conventional aircraft. So delta wings are very, very unforgiving when you get them outside their flight envelope. For example, the SR-71 only has a 10 to 15 degree angle of attack tolerance. It's 10 to 15 degrees positive, about 5 degrees negative, and at that stage it's a departure from controlled flight, as they would say in technical terms. That's a bit extreme. I'm going to actually pay attention to where I'm placing these. A little further back. Now as you fly, you'll be burning off RCS. Usually this is how much fuel will be left when you're ready for re-entry. The Clockheed Martian Pack comes with fuel dump valves if you don't want to use TAC fuel balancer, so you can dump out anything you don't use. And that'll shift you pretty far forward, but being able to move monopropellant from your front and rear tanks can allow you to set up like an extreme forward position for your center of mass for re-entry, and then you can kind of balance it back out so you have better control authority at low speeds. That is essentially the shuttle orbiter. Going back to my previous video talking about wheelbarrowing, this is a very massive vessel. Wheelbarrowing is absolutely disastrous in this. If you start to wheelbarrow, you've lost this thing. But being a glider and a vertical takeoff, a rocket launched type vehicle, it has some advantages. Namely, you can make your nose gear significantly shorter than your main gear. And I'll illustrate the advantages of that. Get these back here. And you don't have to worry about pivot points, you just get as wide a footprint as you want and drop those in there. Angle snap off, because this is down below and angled. These will naturally orient perfectly straight. Okay, with your main wheels longer than the rear, you'll have a natural nose down inclination. And that gives you a lot of freedom in how you come in on your approach. If you're stalling out on approach and you need to get the nose down to maintain forward airspeed, you can even go a little bit nose down if you have to maintain your velocity. Or if you're coming in nose level perfectly, you're still going to get your tail down. And because of the way this thing's built, you have to go about to that angle to start worrying about tail strikes with those wheels that far back. At that point, if you're on a slow approach, you've pretty much stalled out. If you need to go this extreme on approach, things have gotten very bad. Another knock-on benefit of this is once it's down, your wings are angled down, your space shuttle is going to stay down once all three wheels are planted. You can occasionally run at high velocities. It'll push down on that nose wheel and it will tend to wheelbarrow on its own, but we're talking some pretty excessive speeds. I'll try to demonstrate it, but I honestly don't think I can get this thing that fast in a glider test. It's really hard to overcook your approach on this one. But that is essentially constructed and ready for a glider test. Here we are, ready for our self-boost glider flight. You can probably notice it's a little different from when you last saw it. I've got thruster blocks, struts, just general junk thrown back onto it. Have some action groups set up to shut these engines down and lock the gimbal. Once you get into space, after jettisoning the main tank, it's very important that you shut these off. And locking the gimbal is just an aesthetic thing. They tend to flop around and look kind of goofy. This, tends to make it look a little more composed. On brakes, I removed the nose wheel from the brake action group so that all braking force will come from here. It'll still yaw a little bit and shimmy. It'll be getting set down in, well, over here somewhere probably. It's not perfectly level, so you'll see. Beyond that, I'm gonna stop talking and get to flying. You go full throttle, SAS on, full down pitch to counteract the engines, and launch. Speed picks up, starts to stabilize, roll out a bit. You can see those engines just wobbling around. Press 1 and they start to behave themselves again. Disable SAS. Gonna lower the landing gear, or actually lower the landing gear, sorry. And curve back around. Oh. Upset it with the rudder. Did not like that. Who knew that something the size of a small commercial jet does not like to try a knife edge? Very easy to handle on approach. I've had this thing down as low as about 83 meters a second, and it's just perfectly happy. Keep the nose slightly up and hold VSI at 0 at 83 meters a second. Hoping the struts I put on here, this is the first time I've landed it with the struts. Hopefully those will kind of make things a little more solid. Set those down. Nose goes down. Engage the brakes. Still getting some flex out of these landing gear, but it's nothing really major. I do have the reel chute mod, so if I so choose, I could put drag chutes on it, but I'm trying to keep my mod list down as low as possible. And with that, we are down. Put on the parking brake. Open that up. Check that out. Turn the lights on. And we've got a nice, functioning, functional space shuttle. Revert to the spaceplane hangar. So all that tedious, boring crap is now out of the way. In our next video, we're going to be adding the external tank, solid rocket boosters, and this will make orbit. Thank you for watching.